Okay, now we talk about phagocytosis, the mechanism phagocytosis. Now, sometimes in my website, I may have changed a few slides than what you see here in the video, so just be cognizant. Okay, step one in phagocytosis is going to be what I'm going to call chemotaxis and optimization. All right, let's kind of explain it. A microorganism gets in your body. Let's say that it produces some chemical attractant that pulls the phagocytic cell, neutrophil or macrophage, towards it. Otherwise, it may not know it's there. Chemotaxis is a chemical attraction where the phagocytic cell is pulled towards the offending microorganism. Now, once it's pulled towards there, it has to be tasty enough for the phagocytic cell to be able to grab onto it. So chemotaxis is the pulling effect. Opsonization is to make it tasty where the phagocytic cell can adhere to the microorganism. So I go down here. The opsonization is a coating, and there's several things can do that we'll do as we go through this chapter. One is something called complement proteins. You don't know anything about that. The other is antibodies. In order to adhere to let's say the phagocytic cell to adhere, it must recognize and be able to bind to something on the outside of the cell of the microorganism. That's generally a carbohydrate. Sometimes the microorganism, will say, doesn't have those carbohydrates, and it's very slippery. So it's very difficult to bind to. We'll talk about that. So once the binding has occurred, then enzymes in the phagocytic cell would attempt to kill the microorganism. And there are several. Remember the lysosomes and so forth. But sometimes these killing chemicals cannot do it. They can grab, but they can't do it. And that's when you form a granuloma, should we say, a granuloma. A granuloma in clinical is, for example, let's say you're playing football. A running back is running and carrying the ball. Several defense men try to bring him down, but the running back is so strong that the first one grabs on and is being dragged down the field. The second, the third, the fourth, the fifth, all of them are surrounding him, but they can't bring him down. And so that's a granuloma. It's where a bunch of white blood cells surround the microorganism, and the microorganism is right in the middle, but it itself is still living and able to do damage. Okay, now, we've heard of free radicals. I mentioned that in my ANP1, for those that took it. You think of free radicals as something bad. What I want you to now think about is that the human body sometimes uses the free radical to do something. Macrophages and neutrophils will create free radicals inside them to destroy microorganisms. That's what is called the respiratory burst. They use these free radicals to do that. That is one of their big features. In this case, they're using free radicals to do something beneficial. Here's the respiratory burst. You can glance at it. Don't get very heavy into this. There's not really much in the book on it. But again, it's what I mentioned. Now, sometimes a person does not have the enzymes to produce the free radicals. Thus, the phagocytic cell will grab on, but it can't kill. A bunch of them will grab on. And that's what we call chronic granulomatous disease. There's an enzyme defect in your genetics, in that person's genetics, that does not allow them to produce the enzymes to do the respiratory burst. So you can't bring it down. But I want you to pay attention to the chronic. It means then you can just have a granuloma. A granuloma is a spherical mass of immune cells that when the immune system tries to wall it off, but it can't bring it down. I'll tell you a good example. The tuberculosis bacillus is known for this. For some reason, it's hard to bring it down, and it forms this granuloma. When you come in and we do a PPD, if some of you are familiar, to see if you may have been exposed to tuberculosis, if it's positive, then generally you'll do an X-ray. You'll look up at the top area of the lung, and sometimes you'll see this granuloma. Now, what that means, you really have an active case of TB, because right in the middle here would be tuberculosis bacillus entities that if this broke free could go out through the lung, you'd breathe it out through your mouth into somebody else. Okay, so this is a granuloma, but some people have chronic granulomatous disease. Okay, so again, chemotaxis, opsonization for phagocytosis. All right, here comes another organism involved in the second line. Real phagocytosis was in the second line. The natural killer cell. All right, I want you to listen to this. We have three basic types of lymphocytes. The T cell, the B cell, and the natural killer cell. Let me do it again. The T cell, the B cell, and the natural killer cell. The T lymphocyte and B lymphocyte are in the third line of defense, which we've not talked about yet, except just to introduce it. The natural killer cell is a lymphocyte in the second line of defense. The T cell and B cell are in the specific line. That means they're cut and snipped. The natural killer cell, that's why they call it NK, is natural killer, is in the non-adaptive. It goes after many things. What it basically is a large granular lymphocyte. Remember I mentioned a granule before. That's a stained vesicle. So it's a large lymphocyte with lots of small granules. What's it looking for? Now, you got to decide what's it looking for, because you don't want it to kill some of your cells. So this is what it's looking for, and listen to me well. It's looking for cells that don't have any surface receptors at all. CDs. Remember CDs, cluster of differentiation. See, if you don't have any CDs, it has to be foreign, because all your cells would have certain CDs. So if it doesn't have any CD, it's foreign. It could be a microorganism, or it could be a foreign body, like a piece of metal or something. They wouldn't have any CDs. Or it's looking for something that has the wrong MHC1, which we'll be talking about, or a mica. Now, a mica is a distressful flag put out from a cell if there's distress inside. Now, lymphocytes go for these cells, but you wouldn't know what. See, the only thing a cell can look at in another cell is on the surface. You can't see inside the cell. So if there's activity going on inside the cell, then the cell may put a mica out and say, please destroy me. What activity could be going on? So you really have to study this. Viruses do their work inside a cell. They are intracellular actors. Cancer does its work inside a cell. So sometimes a cancer cell will pull out a mica or a virus. So we always are producing cancer cells, you and I both. But fortunately, they oftentimes put out a mica and we pluck them out and they never get anywhere. So if the cell displays the wrong MHC, which we'll call later a major histocompatibility complex, or mica, it will attack. Now, a no-kill sign that cells sometimes is an LY49. So an LY49 receptor placed out is like a flag that says, hey, I'm fine inside, keep going. Unfortunately, we have found recently that cancer cells have found a way to put LY49 out. What does that mean? It would ignore it and the cancer could grow quicker. All right. When the natural killer cell encounters, now see, check up here, CD16 and 56. See that cluster? So in other words, how do I identify natural killer? If we did an assay, if we saw 16 and 56 on the surface, then we'd know it's a natural killer cell. What happens when the natural killer cell grabs on and does this thing? The natural killer cell then does not actually get into a physical fight. It shoots stuff out from itself. It shoots something called perforins and granzyme. The perforins come in and perforate a hole in the microorganism. Granzyme chemical slips through and destroys the genetic material in the nucleus of that particular entity. It can also induce apoptosis. Go back and study this word. Apoptosis, in case you forgot, is programmed cell death. So it could turn on internal machinery in the cell to induce that cell, like cancer cell or virus, to kill itself. It can also secrete in the surroundings some potent inflammatory substances that will cause inflammation to occur, where other white blood cells can come in and destroy it. So the natural killer cell is a very vital cell to keep things from not going too far and getting into the third line of defense. Okay. We now go to inflammation. I'm going to start a separate video on inflammation.